So the quadratic formula is the last method I'm going to show you for solving a quadratic. And like I talked about in the previous video, is the quadratic formula comes from completing the square. If you want to Google it, you can look up the proof by completing the square. And it'll prove where this formula comes from, which says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. You need to commit that to memory. It will not be given to you as a formula on the test. You will need to know it. So I recommend, just like I did with the slope formula, write it down every time and fill in the spots. But that formula does come from completing the square. But I just need you to memorize it. So when you have a quadratic that is not factorable or it's hard to solve, you can always plug it into the quadratic formula. The quadratic formula will solve for x no matter what type of quadratic it is. So here I've got 9x squared plus 3x minus 2 equals 0. You always want it to be set equal to 0, so we're good there. I also want you to just make a habit of writing down a, b, and c, because if you do that, you'll tend to make less mistakes on plugging into the formula. So A is going to be 9, B is 3, and C is negative 2. So when we use the quadratic formula, until you know it by heart, go ahead and just rewrite it every time. It'll help you remember it. So it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're just going to plug in your a, b, and c. So I'm going to have negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, it's very easy to make a simple sign mistake, so a couple things as I rewrite them, I'll kind of point them out. I've got negative 3 plus or minus the square root of. If b was negative and you square it, make sure you put parentheses around it on the calculator. If you don't, it just squares the number and not the negative. And if you square anything, you're going to get a positive number. So just be careful. I put parentheses around it, but if it was a negative 3, you also need to put parentheses around it. So we've got 3 squared is 9. And then I've got the product of negative 4ac. So if I have a negative and a negative, that's going to give me a positive. And then I've got 4 times 9 is 36, times 2 is 72. And then that's all over 2a, which is going to be 18. I'm going to move this up here because I'm running out of room. I've got x equals negative 3 plus or minus the square root of 9 plus 72 is 81 over 18. And then you're going to simplify. Here, 81 is a perfect square. The square root of 81 is 9 over 18. Okay? So what that means is you've got two answers. You've got x equals negative 3 plus 9 over 18, which is going to be 6 over 18, which will reduce to 1/3. But then you also have, so this is one solution, you also have x equals negative 3 minus 9 over 18. So that's going to give you negative 12 over 18, which will reduce to negative 2 over 3. So don't forget your plus or minus. That's going to give you two solutions. So you need to work out both of those separately. Okay, let's look at the next one. We've got x squared plus 5x plus 1 equals 0. Here, again, list out your a, b, and c. A is 1, b is 5, and c is 1. And with our quadratic formula, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've got x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 1 all over 2 times 1. So x equals negative 5 plus or minus 25 minus 4 all over 2. Which is going to give me negative 5 plus or minus the square root of 21 over 2. Now notice that 21, its prime factorization is 7 times 3, so it will not reduce or simplify anymore. So that is your answer. So you've got two answers. You've got negative 5 plus the square root of 21 over 2, and negative 5 minus the square root of 21 over 2. And you can leave your answer in that form, or WebAssign or your homework lumens will take it as split up as negative 5 over 2 plus square root of 21 over 2. These two things are equivalent. That 2 is dividing into both of those terms. So either way you want to write your answer, I usually keep it in this form, but just if you see this form, I need you to know that it's the same as that form. Okay, let's look at another example. Notice this one is not set equal to 0, so that's what you're going to do first, is you're going to move everything to one side. So I've got x squared plus 3x minus 9 equals 0. And we're going to do the same thing. A equals 1, B equals 3, and C equals negative 9. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Clean that up a little bit. You got negative 3 plus or minus the square root of 9. The two negatives are going to give you a positive, and then you've got 4 times 9 is 36 all over 2. So you've got x equals negative 3 plus or minus the square root of 9 plus 36 is going to be 45 over 2. Now 45, if you do the factor tree, is 5 times 9, and then 9 is 3 times 3. So it does have a pair of 3's, so it can be simplified. So when you simplify this, you're going to have negative 3 plus or minus. The pair of 3's will make the perfect square, so it comes out, and the 5 stays under over the square root of 2. Over 2. So that gives you your two answers there. I didn't have an example on here, but you might see something like this on the homework. Say you worked it all out and you had a -4 plus or minus 2 square root of 2 over 4. Let's do that. Um, Remember what I said earlier, the denominator is dividing into each one. So if it can simplify, make sure you simplify it as much as you can. So if you pull it apart, I've got -4 over 4, which is -1, plus or minus. You just are going to look at the what's not under the radical. Would 2 over 4 would reduce to 1/2. So there would be an understood 1 on top. So 1 square root of 2 over 2, because that would reduce to 1/2. So that would be the simplified answer there. So if you run into a example or a question like that on your homework where you can find the common denominator of those three, not under the radical, but out in front of the radical, then you need to reduce that as much as possible. Let me know if you need any help or any questions. Email me or Canvas message me.